All right, so, oh, you want this projector on?
Did Oracle buy out Sun Microsystems?
Yes. Yep, purchased the company.
They didn't just like change their name and get bigger.
They both existed. Oracle was a database, well, still, Oracle is the name of a company, but it's also the name of their flagship product. It's a database management system called Oracle. So they were already a big, big company, specializing in database and data security. So when they bought Sun Microsystems, they kind of got the Java and server division. Sun Microsystems was kind of an IT server hardware, server software type of software industry thing. So they kind of picked up some industries that that Oracle wasn't already playing in. Oracle had a product specifically, a version of Oracle specifically for Solaris, which was Sun Microsystems' Unix version. So really what Oracle brought in-house was one of their prime targets for their Oracle database. The architecture they were writing their software for. So it was a pretty decent fit, I think. Okay. So we looked at command line arguments there from a Java perspective. So now what I'm going to do is just to show you a little bit more about how these languages are so similar. Let's go in here and let's we'll do our for loop for printing out the numbers 1 through 5. Okay. Pretty shortly here, I'm going to move into Eclipse, which is going to be the tool we're actually going to be using in here, but let me just keep it out here for right now. So I'm going to create a for loop for int I is equal to 1. I is less, well, what did I say, 1 through 5? Yeah, I is less than or equal to 5. I is equal to I plus 1. So that's the header for my for loop. Okay, so wrote the code. This is the same thing as we had in our keynote slide. So I starts off at 1, keep going as long as I is less than or equal to 5, add 1 to I each time through, print out I. So if I run this, so since I made a change, I need to compile it again. Then I can run it. We get the numbers 1 through 5 displayed. Okay? Now, interesting thing. I'm going to just copy that for loop here real quick. Go into my C program. I'm going to switch this back to C so we can see how old it goes. Reason there's two things here rather than just the one thing that we have in Java is this thing is, well, modern day it's called a string array. Back then it was a pointer to a character pointer which pointed to another pointer. So this was two dereferenced memory addresses. Not that important right now. We'll talk about pointers plenty in here. But the weakness that arrays had back then was that they couldn't tell you how many values they had. So this first one, int argc, is the argument count. In Java, we can do a single loop that looped through all the elements in Elephant that we did right before break. Elephant knew how many buckets it had in it. It knew how many command line arguments there were. In older languages like C and C++, along with the array, we had to pass in how many things there were. So that's why there's two elements here, two inputs, versus one on the other side. So relatively unimportant in the big scheme of things right now. Now I'm going to paste in my Java code. So I just pasted my Java code into a program that was into a language that was written at least 30 years prior to Java existing. Okay? So I just made a fairly small change. Just changed the way I print something. But the entire structure of that for loop, I did not touch. Right? Okay. One, two, three, four, five. Oh, I forgot to do a carriage return. Just don't strike my face. There's our backslash n. 1, 2, 3, 4, 5. That's a language that was created a minimum of 30 years prior to Java being invented. And I only had to change one line of code for that program to still work. I didn't even change it drastically. Okay? So, kind of makes sense how all languages are pretty much the same, especially C-type languages. But once you learn how to program in terms of variables, asking questions through conditionals, and loops, learning the syntax for doing those things in different languages is not that difficult. And then over time, using that language, more stuff will just be part of your memory as opposed to you going and looking it up in a reference book or something. But who cares? You know, it's not like you're going to become a Java programmer someplace and your boss is going to lock you in an office and say, okay, do this, you can't use any reference materials. You know, life's not always a test. You know, there's a competence that goes into it, but having reference materials is fine. Okay, so that makes sense? All right, so now let's go ahead and transition over to Eclipse, which is the tool we'll be using here. So I think we can all appreciate the old school way of doing this. All right, so just quickly, I'll show you where Eclipse can be found. The website is eclipse.org. And once you get here, go to Downloads. And if you are doing this for a Mac, the thing you might be tricked into getting is the Eclipse Standard 4.3.1, which would be fine, but that's way more than you need. I like to get the Eclipse IDE for Java developers. This one right here. Okay? So it's automatically detected that I'm on a Mac, so it provides me the two different installs, either the 32-bit or the 64-bit version for a Mac. Get whatever one you want. For Windows, same thing's true. So it's Eclipse is available for Windows, Linux, and Mac OS. So you want Eclipse IDE for Java developers. It doesn't matter if you get the 64 or 32. Get the 64, but it's not going to make any difference to you. All right, but make sure this is the one you get. Make sense? So that's the tool. And once you get it, it's actually a self-contained program. So whether you're on a Mac or a PC, it'll just be in a folder. You can just drop it wherever you want it. Just wherever you can remember to get it. You can even leave it on your desktop if you want. So then when you open up Eclipse, here, I'll actually kill Eclipse and reopen it so you can kind of see what the launch looks like. So I'll go ahead and open up Eclipse. I think I'm using the newest one. It's possible there's one newer than Kepler, but it won't really matter. Okay, so Eclipse will look like this. The very first time you open it, I probably hit the checkbox that said, don't ask me anymore. It asks you, where do you want your workspace? It gives you a suggestion. I always put my workspace inside my Dropbox. How many of you are Dropbox users? How many of you have never heard of Dropbox? So we all heard of Dropbox, but only 2 of you are Dropbox users. Why is that? Dropbox is like the best thing since sliced bread. Dropbox.com is the website. Go here. See, I have this little icon up here, it has a little green check mark on it. This blue guy up here. Dropbox. It's free. You get 2 gigabytes of cloud storage for free. Don't have to put a credit card in or anything. Get it, especially for homework. I mean, I pay for Dropbox every year because I store a lot of stuff in the cloud for my businesses and things like that. But from a student perspective, it is 100% free. Don't have to put in a credit card. You get 2 gigabytes of storage. Go ahead.
Why do you prefer Dropbox to Google Drive?
Well, several reasons. Google Drive came after Dropbox, so it's trying to do the same thing that Dropbox is doing. Dropbox has kind of become the industry standard for cloud storage, so a lot of applications plug directly into Dropbox. So they'll allow you to sync things that way. They both do very similar stuff. I just have found Dropbox to kind of be the most ubiquitous. There's an app for your iPhone. There's one for Google Drive as well. But so many applications will allow you to export directly to Dropbox. But in any case, it's free, 2 gigabytes. What it does is it installs a folder on your computer. And anything that you put in this folder automatically gets synced to the cloud. So as long as you have a green check mark there, it's in the cloud. Somebody could literally come and cut your computer in half and you haven't lost anything. Anything you put in that folder is magically stored in the cloud. You don't have to upload it. You don't have to do anything. What's really cool about this is, let's say you have a laptop and a desktop computer and you're out at a coffee shop working on some document. Always work out of your Dropbox folder. So I have all those files that I work on constantly inside my Dropbox folder. It's a local folder living on my computer. I'll open it up. I'll be working on it. I'll hit save as long as I have the green check mark. Close my laptop. Go home. Go sit down at my desktop. I'll have the green check mark up there because it's been on and it's been syncing. The file I was working on at the coffee shop's already at my house, already ready for me to open. I just open it. Free.
iPad too?
iPad too. Free, 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 free. And you never have to worry about, oh, did I lose my jump drive? Oh, it's corrupt. Oh, my dog ate my homework. Well, no big deal. It's stored in the cloud. And it's free. It's free. It's free. No excuse not to use this, especially for at least your homework assignments. Just work out of that directory for all your homework assignments. So God forbid your hard drive crashes or something like that. You've literally lost nothing and it was effortless. As long as you save everything in that folder.
Transfer from Windows to Mac?
It doesn't matter. It's just a folder. It's a magical folder.
Sync back and forth.
Oh yeah, it's just a folder. That's it. There's a Mac version of Dropbox, there's a Windows version of Dropbox, and after you install it, you don't even think about it. You don't have to do anything. You don't have to start it. When you turn your computer on, you'll have the little dude will be up there and he'll be spinning. No big deal. Good to go. I think on Windows it's down here. So anything you want to not lose, put in that folder. Up to 2 gigabytes worth of stuff. And it will do the rest. Make sense?
We're required to use Google Drive for school and stuff.
Okay. Yeah, I mean, Google Drive is an equivalent technology. Nothing wrong with Google Drive. Solves the same problem. Stuff is not just on your computer, it's also in cloud. So if computer is sawed in half, no biggie. Other than my computer got sawed in half.
Can you
All right.
put pictures in there?
Huh?
Can you put pictures in?
It's a folder.
Anything.
Anything you can put in any folder on your computer, you can put in the Dropbox folder because it's just a folder. That's all it is, with a space limit of 2 gigabytes. Unless you get really addicted to it. Like, for instance, my brother, he's got a 5-year-old kid and a 2-year-old kid, so he's got zillions of pictures and videos and stuff. So I set him up on my Dropbox account as one of our team members. So he has like 3 terabytes of space, for like $125 a year. Sometimes the problem is you have more storage in the cloud than you have on your machine. Especially with our laptops today going to these solid state drives, they don't have as much storage on them. So I have to selectively choose what files I want to sync. But in any case, Dropbox is a highly advisable tool for you to look at. If you're not already using a different technology, I think Dropbox, even against Google Drive still has some limitations on what kind of files you can put in there, does it not, Lauren?
What?
Doesn't Google Drive have some limitations on what kind of files you can put in there?
I don't know. I don't use that much, but I only upload school stuff and then my other Google account for videos.
Okay. Yeah, for some reason, I think there might be some limitations on file types you can have in Google Drive. There's definitely limitations on file types you can have in Microsoft SkyDrive.
Yeah, that has got
Major limitations.
Yeah.
So Dropbox is, as far as I'm concerned, is as good as any of them because it literally is just a folder. If you could put it in a folder on your computer, you can put it in Dropbox. So highly recommended, and it's free. Okay, so that's a scoop with Dropbox. In any case, when Eclipse first opens, it's going to bring a little window up that says, where do you want to put your workspace? So I usually put my workspace in my Dropbox. That way anything I do in here is magically stored up there. So if this machine gets out in half, everything's fine. Okay, so once you hit OK to that, there's usually a little check mark that says, don't ask me again once you set it, but whatever makes you happy. We're going to create a brand new project. So I'm going to come over here to my Package Explorer. I'm going to right click. I'm going to say New. You can similarly go up to File and go to New. We're going to create a Java project. And I'm going to call this guy CSC535. I don't already have one of those, do I? Good. So there's my CSC535. Oh, I do have one from last semester. Okay, hold on. I got to delete that. So I'm going to create a new CSC 535 Spring 2014. Perfect. So that's going to create this empty folder that has a folder inside of it called SRC for source. And there's nothing currently in there. So I'm going to go in here and I'm going to right click. I'm going to create a new class. And I'm going to call this class driver. For no good reason other than you've heard of software drivers before. Like when you buy a piece of hardware and you need to install a driver for it, like a video card or something. A driver is a fancy word for saying computer program that knows how to run this piece of hardware. Okay? And I said that all programs begin and end with main. So typically and our programs are going to grow in here where we're going to have other .java files that are all going to work within one program. So one of those .java files is going to be our driver. It's going to be the guy that starts the program going. So I like to call that driver. Nothing about Java requires us to do it. I just like calling that center guy driver. So I'll name him driver. It'll create for me this file. It'll even name it driver for me. This is the same reason why this was not necessarily obvious to us when we did it out at the terminal. I named it who.java. I had to make my class public class who. They did it for me in here. So you never become aware that this class name must be the identical name to the name of your file, driver.java. Because it just does it for you. Okay, but they must be identical. All right. So I'll type in my public static void main string array args. Okay. And then we'll do our system.out.println hello world. And then instead of doing that javac, blah, 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 all that crap, you just come up here and hit play like it's a DVD player or a VCR. And there you go. That's your program. Okay, now, interesting point here. Maybe more of a word of warning. I have been known, hint, hint, to give a pop quiz having you write a working Hello World program on paper from memory in this course. Hint, hint. So it would behoove you to commit this to memory. I'm not a big advocate of memorizing a whole lot of stuff, but I think there are some core things with anything that should be memorized because this, what you're looking at right here, is literally the starting point for every Java program you ever write. With the exception of the system.out.println hello world, but even then, I usually throw that in there just so I can run it and test it and make sure my environment's working correctly. This is the simplest program you will run into. Usually the first program you write in any language is the proverbial hello world program. Okay? So I would commit this structure to memory and be able to repeat it. All right, make sense? Now you'll never know when it's coming. In fact, this might be an empty warning. I'm just telling you, I've been known to do such a thing. Usually it's to embarrass students. Because I have a hobby. I like human misery. You know, I don't want anybody to get hurt, but I want to see them suffer. So that's probably why I became a professor. It's like the perfect. You only work 13 hours a week, 8.5 months of the year, and you get to see students suffer all the time. And when you're in a bad mood, you can just give hard homework assignments. It's great. Oh. Plus cafeteria food. Our cafeteria here is pretty good.
Yeah, I had some burnt lasagna for supper.
That's nothing wrong. You eat the cafeteria pretty often?
No.
Oh. Lunch. Lunch is where it's at the cafeteria. Breakfast is pretty good. Lunch is the best. Dinner is a repeat of lunch, but less good.
Burn, yeah.
No. Was it that burned?
Yeah, well, yeah.
So that's like your one experience in the cafeteria was that one?
No.
Plus
I
it's
eat here once
plus
in a while.
plus it's cheap for faculty staff. The student, huh? Oh, I'm telling you, the lunch there is good. They have like the stir fry station where they'll make you your made to order pasta, and they got a Subway in there. They have an ice cream stand. They have a salad bar and soup. I gave up on that.
Oh, when did you give up on that?
After my surgery, when the doctor told me I was no longer gluten intolerant.
Oh.
I was in Vegas eating a 12.5-pound burger for autism.
You mentioned that.
And I ripped a hole in my stomach. I finished the burger though. So he had to go in there and sew me up and said, "No, you're fine. But whatever he used to let me eat a bunch of food, I can't do anymore." He must have nicked something. All right. So, in any case, here's our basic Hello World program. So we're going to go ahead and remove that, and we're going to include some of our loops in here so we can kind of look at the difference between them. So far in our slide set, we have written some a for loop and a while loop, both of which count between 1 and 5. Okay, so we're going to look at these guys in our code in Eclipse and see kind of what the difference is. Why would one write a counting loop in a for loop rather than a while loop, and vice versa? All right, so I'm going to start off by creating our while version of this. Int I is equal to 1, while I is less than or equal to 5, system.out.println I. And notice that it did all the indenting for me. So when I was here and I pressed enter, it kicked me in where I wanted to go. And that looks like a tab to me. But I think you can edit it, but I never change it. Okay, so if I run this, I should get the numbers 1 through 5 printed to the screen. I forgot to do what? I did this on purpose, of course. Yep, this is an infinite loop. Just kept printing out 1. Why? I starts off as 1. Is 1 less than or equal to 5? Yep, print it out. Is 1 less than or equal to 5? Yep, print it out. Is 1 less than or equal to 5? Yep. So I need to make sure I change I so I don't have an infinite loop. So I becomes 1 bigger each time. Now I'll have 1 through 5 that get displayed. Okay. So that's the while loop version of this. Now I'm going to go ahead and comment this out for right now. So multi-line comments in all C-type languages, C, C++, Java, C#, Objective-C. It's a /* finished by */ Everything in between those two symbols is ignored, treated as a comment. That's the multi-line comment. Single-line comment is 2 // followed by whatever you want, but when you get down to the next line, it's not a comment. Okay, so I'm just going to comment that out for right now. That way we can still see it, but I'm going to write the for loop equivalent. But it won't execute. It's for human eyes only. That's the point of a comment, okay? So I'm going to create a for loop where int I is equal to 1, I is less than or equal to 5. Interesting point about spacing you asked earlier. This less than or equal to thing here cannot have a space between it. That has to be one solid operator. Okay? I is equal to I plus 1, but we can certainly say I equals I plus 1 without any spaces in there if we wanted to. So there's the for loop equivalent to that for a counting problem. Run that. There's my 1 through 5. So maybe one obvious thing, benefit of a for loop for counting problems, is that it's more difficult to forget to change your counter because it's part of the syntax, right? Because up here I forgot to put this line in. Of course, I purposely forgot. I was testing you. That's what I was. So, but a for loops is this part of the syntax. We're able to, you're almost coached into not forgetting to increment your value or decrement or whatever you're going to do to it to change it. Okay? So that's one advantage of the for loop. What will the output of this program be? Notice that I've commented out the for loop down here, so that won't be executed. So my program consists of this right here. And remember, all programs begin and end with main. So when I run this guy, it will come to line 1 of main and execute till it hits the end of main. Main might take us off on a wild goose chase into other places, but right now everything starts at the very beginning and ends at the end of main. What will the output of this program be? Go ahead.
It'll go through your integer things, and so it'll do the 1 through 5, and then the last line says system out print line I on the last one. So that's after it's done 1, 2, 3, 4, 5. So then it'll now I is 5, so it will print 5 again.
Okay, close.
Or is it going to stick with the original I?
Well, okay, interesting question. You were right the first time, but you forgot to increment I the last part. I is 5. 5 less than or equal to 5? Yes. Print out 5. 5 becomes 6. Spin back up. Is 6 less than or equal to 5? No. Fall past the end of the loop. Print out the current value of I. What's the current value of I? 6. So this will print out 1 through 6. Make sense? Okay. Similarly, what would the output of that program be? Seems that it should obviously be the same thing, right? It won't be. I was hoping none of you saw this little red squiggly here. Did you see that?
Under the I?
Under the I. One of the things an IDE does for us is it kind of does like spell checking, similar to like Word. We have a syntax error here. I also have a little X thingy over here saying, hey, something's wrong here. Problem is that it's going to say no variable of I named I has been defined. I cannot be resolved to a variable. Well, what do you mean? I defined it right there. What are the advantages of a for loop? Well, let me ask it this way.
Is it localized to the variable?
Well, would you agree that I is basically a throwaway variable? It's created only for counting really quickly, right? We create a variable named I just so we can spin through the numbers 1 through 5. After we've done that, do we really need I anymore? We might need an equivalent to it later on, but really I is a little throwaway variable. Usually when we create variables, we want them to have meaningful names. But in this case, I, J, K tend to be our go-to little throwaway counting variable names. An advantage of a for loop is that because the variable definition is part of the syntax of the for loop, its scope variable scope. This is where a variable can be accessed. Did I spell that right? Ish? Good enough. So variable scope is a fancy way of saying, where can I see this variable? Where can I use this variable? The scope of this variable right here, because it was defined as part of the for loop, lives and dies with this for loop. So as soon as this for loop ended here, I was garbage collected. So coming back into here, Java has something called automatic garbage collection, which means that when we are done with a variable, when it can no longer be used, when it's out of scope, Java has a virtual dump truck driving around that cleans up the mess, releases that memory that we were using up for that variable. Make sense? Java does that automatically for us. In older languages like C++ and C, we were responsible for cleaning up our own memory. Okay.
So then how would you say that if this was C or C++ or any of that, how would you go about getting rid of I and making sure that wasn't there anymore?
Yeah, I was afraid I was going to walk into that.
Like,
No, it's it's actually a good question because I sort of kind of partially lied to you. Primitive types are primitive types in all of those languages are automatically garbage collected. But garbage collection wouldn't have been the name for it historically. But let me answer your question by showing you what you were responsible for. So this string array args thing, I'll just do a real quick example. If we were doing this in Java, let's say I wanted to create an integer array called AR. This guy's going to be a new integer array, size 10. Who cares what that means? But it's a new kind of variable that we don't know about yet. But the important thing is we use this new keyword. This guy's job is to give us memory, create memory, okay? In Java, after we're done using AR, it magically disappears. If we were in C++, that same line of code would work, but we would have to say delete AR. We'd have to, on purpose, get rid of that memory. Otherwise, we'd have something called a memory leak. Heard of those before? Okay. Memory leak is when we have memory that is no longer accessible, but we can't access it, but it's not freed up. So other things can now overwrite that memory. That would be a memory leak.
it doesn't like it.
Yeah, it doesn't like it because you can't do it in Java.
Oh.
Yeah, I'm just saying if this was in C++, this is how you would do it. Yeah, Java doesn't require it. Java does automatic garbage collection, so it does not have a syntax for deleting things. Okay. Similarly, if we were doing this in C, the C equivalent of this line, so we go a little older, we would say int pointer AR is equal to malloc 10 times size of int. these two lines are historically equivalent. So these two create the same thing. But we are using memory allocate in the old C language, which creates enough memory to hold 10 of these guys and returns for us that memory address. We'll talk a lot about memory addresses, so don't try to think about this too much right now. I'm just kind of giving the example. So then in C, we would then be our responsibility to dealloc AR when we were done using it. Okay, so those, go ahead.
And alloc is probably like allocate or something?
Yeah, malloc is newer than alloc. There was an alloc historically. Objective-C still uses alloc. Objective-C does not hide a lot of the details that Java hides from us. But the important thing here is that Java does not require us to clean up after ourselves. It goes through and does it for us, which actually is a performance hit because it has to have that garbage collection, which is constantly checking memory. We have this extra thing that's going up, cleaning up after you. It takes time, takes CPU cycles, and that becomes problematic in the mobile space. The early iPhone applications, even though Objective-C does support automatic garbage collection, it was disabled when you were writing iPhone applications. As an iPhone developer, you had to deallocate your own memory so that you weren't using battery life, having an automatic garbage collector running on your iPhone all the time to clean up after you.
I read about that when I was doing my research, but I didn't know why.
Yep.
I don't know why.
Now they allow it because they figure battery life is so good and the processing power is so good now that the amount of extra CPU cycles that it takes, because these mobile devices are, what I'm holding in my hand right now is many, many, many thousands of times more powerful than a supercomputer was 15 years ago. I mean, it's amazing what technology, what we have in technology today. So they've kind of done away with that idea. Now garbage collection is done for us, but that was the rationale behind it. So in any case, Java doesn't require us to pick up after ourselves. Just does it for us. So back to the scope of variables though. Because this variable was defined here, it lives and dies with this for loop. So as soon as this for loop concludes, as soon as we get right here, notice for a single line comment, only everything after the 2 slashes is treated as a comment. That curly brace is not a comment in that case. Go ahead.
So if you delete the comment things up there to turn the top ones green, right?
Mm-hmm.
Can I just use?
Yep. This
Now
I
it doesn't
conflicts
have
with
your
that.
I.
Yep. That's why I had it commented. Yeah.
Well, why doesn't it want you to use I twice? Like, why
Because
doesn't it
this I already have an I in scope.
Yeah.
This I right here,
Yeah.
its scope is everywhere inside of this main method.
Right. So why doesn't the for loop change the I back to 1?
I could do that. I would have to just take int off the front. It didn't like me redefining I because there was already an I defined in this scope.
I gotcha.
Okay, so the idea here is that since I've defined an I outside of my loop here, this I has a scope of anywhere inside of main. So that is, there is already a variable named I defined inside of main. So when I got to this for loop, it doesn't like me trying to redefine I because there already is an I in this scope. Even though this is a more local scope, this for loop creates its own mini scope inside of the scope of main. Because an I already exists, this guy isn't allowed. Okay? But actually, even then, I'm only giving you a partial truth because we'll have an exact same example of this soon, where I can have a global variable name I and a more local variable name I that shadows it, that supersedes it, if you will. So really treat for loops as special cases. But for what we know right now, this explanation is good enough. But because for loops really are special cases, because it's the only way that we can create a scope within a local scope. So we're going to call the scope that is inside of a method like main, to be our smallest scope, with the one exception of a for loop creating a scope. Yeah.
So say you want to make another thing now, like with another for loop the same as that one, but you don't want to redefine, like you still want to put int I. So after the second to last curly bracket, can you put another public static void main, then there will be.
No, you can't do that. Yeah, this is a method. When we talk about methods, that'll make sense. But you can only have one method named main. It's kind of a special case, and that'll make a lot of sense when we write our own methods.
Okay.
So for right now, let me comment this out again up here. So we have this for loop. This variable right here is the local variable that lives and dies with our for loop right here. So as soon as we hit the end of this for loop, it's as if I never existed. So when I try to print it out here, it says, sorry, I've never heard of I. Okay? Now, to get around that with a for loop, I can say int I, let's say I do this. I'm going to try to trick you. I'm going to say int I is equal to -7. Then inside the for loop, rather than defining I, I'll just set the value of I. So I took the int part of it. That's how we define a variable. Int I equals 1. We defined a variable named I, set it equal to 1. But I took the int part off of it inside that for loop and just said I equals 1. This assigns the value of 1 to a variable named I that already exists. Okay? And because I defined I here, which is inside main, it also governs the scope inside of the for loop. I could say int j inside of here, and now inside of this for loop, I would have access to a variable both I and j. J is local to just the for loop. I is local to everything from this point forward inside of main. Yep.
So since you established int I equals -7 up there in the for loop, do you even need that int something equals 1, or can you just get rid of that?
You actually could get rid of it. So you could say you could just leave that blank if you wanted to. You do need the semicolon. It's part of the syntax.
Oh, yeah.
But I'll show you in a second why you might leave that blank. But for right now, I'm just not going to redefine it. I'm just going to say, I'm going to use the variable name I that already exists. I'm just going to set it equal to 1. Okay? So this will go through, and we've already seen this code right here will print out 1 through 5, right? Now the question is what will print out here? Notice it's no longer complaining it doesn't know about I, because I has a scope that's outside of the for loop. What will it print out? 6 or -7? So we got 1 vote for -7. Anybody going to back them up? Are you willing to bet your grade on it? You are? Okay, this prints out a 6. Okay, 1, 2, 3, 4, 5, 6. What happened here? We're keeping a running total. I'll just do it up here in my comments. We create a variable named I. I started off as -7, correct? I'm just kind of pretending that I'm memory up here. So I create a variable named I, started off at -7. First line of my for loop, I set the value of I equal to 1. Overwriting that -7 forever. It's gone. I changed the value of I in memory from -7 to 1.
Because you put it in the...
Well, it would be the same thing if I did this.
Oh.
It was just after I defined it. I defined I right here. I brought it into existence by giving it its type, followed by its variable name, and then I gave it an initial value of -7. So it was -7 right here. If on this line I changed it to 22, then it just became 22. Then when I got to this line, I changed it to 1. So now it became a 1. Because we're operating within the same scope. When I say I right here, I resolves to the same I that was defined right here. Because this I governs the scope that's inside this for loop. Go ahead.
So how do you like ask? It's like say you want to create like a thingy. Like how do you ask people to like input a number that they want to input?
We'll get to that. It's probably next class somewhere in there. We'll do user input output. It's actually uncommon now. Most classes don't even teach it, but we'll use something called a scanner to do it because it's kind of helps us with something called streams. But it's actually not that common anymore. Most programs usually have like a text box. You just type in what you want and hit submit because you don't really have a whole lot of command line programs. Okay, so anyways, I defined a variable named I, start off at -7, change I to 22, then I changed it to 1 right here. Spun through, printed out 1 through 5, 5 became 6, 6 less than or equal to 5, nope, fall out, print out the current value of I, which is 6. It does not revert back. That make sense? Because it was only -7 for one line. Then it became a 22 for one line, then it got changed to a 1. So I really wasted my time here and only partially wasted my time here. Okay? Does that make sense to everybody? Because I'm going to trick you again. So I'm going to define a variable named I. Okay? I'm going to say I equals 1 right here. It's going to print out 1 through 5. What's I going to be equal to here? Would you believe this is a dry campus? So what's I going to be equal to here? 6 again, right? Okay, same as before. So there's our 1 through 6. All right. Now I'm about to trick you. Are you ready? So I changed 5 to -5. So I starts off as 1. Is 1 less than or equal to -5? No. So how many times will I execute the body of this loop? 0 times. Remember, for loops and while loops are both pre-check loops. We ask the question before we execute the body of the loop. So in this case, because of the way I've written it, the answer to this question is false the very first time. 1 is not less than -5, less than or equal to -5. So the question is, what will print out here? Because I never gave an initial value to I. It's going to be a 1. Why? But that for loop never executed. It did read that far because of the order that things happen in the for loop. For loops do this. This part happens once and only once, and it happens first. Then we ask the question. If it's true, execute the body, then do this, then ask the question again, then execute the body, so on and so forth. This part happens regardless of what the answer to the very first question is. Make sense?
But isn't it scope only within the...
Nope, because I defined it here.
Oh, yeah. Right.
Yep. If I had defined it in here, yes, you're right. Its scope would be local to that for loop only. I think that's probably good for now. All right, so that's the scoop with our for loops and our while loops. So I might say that one of the advantages of a for loop, besides it kind of reminding you to change your counting variable each time, one of the advantages is that it allows you to deal with throwaway variables very easily. And to kind of give you that as an example, let's say we are doing this as a while loop. It's not uncommon to have a program that has multiple loops in it. So now I have my while loop. I'll have int I equals 1, I is less than or equal to 5, print out all those numbers. And now let's say that I want to print out all the numbers between 30 and 40. So I'm going to have another while loop. Well, I can say int j is equal to 30 while j is less than or equal to 40. System.out.println j, and then j is equal to j plus 1. So this will print out 1 through 5. This will print out 30 to 40. Okay, but now I had to waste an extra variable. I create a variable named j, which is also a throwaway variable, just to hold the numbers 30 through 40. But what if I wanted to use I again? Well, I could have come in here. I could have said I is equal to 30. I'm not redefining it. I'm just resetting it. Okay? I know that when this while loop's done, I is currently 6. Well, I don't want it to be 6 anymore. I need it to be 30. So I'm going to set it to 30, keep going as long as I is less than or equal to 40, print out I, and then change I to be 1 more than it used to be. Okay? But I had to remember that I already had a variable defined named I. And keep in mind, you might have 300 lines of code between those two. You might not remember what you had written all the way up there. Go ahead.
Can you make it print so that it's so that like it prints all on the same line with like spaces between them?
Yep. Instead of saying print lane, you just say print.
But will it put spaces between them?
You'd have to add the space, but as of right now, it'll just print it all on one line.
Okay.
Like that. 1, 2, 3, 4, 5.
0.
Well, the 30 was put on there because that was the first one we did the print len. So it printed out the 30 and then kicked it down the line.
Oh.
We'll learn how to add the space here probably next class. All right, so this is the while loop version of this. So now an advantage of a for loop. So I'll go ahead and I'll do my for loop for I equals 1, less than or equal to 5. And I'll copy this code. 30. Oh, I need to change this back to a positive 5. Less than or equal to 40. So I have two separate for loops there, both operating on a variable named I, both of which I defined inside the for loop. Perfectly acceptable, because this I lived and died with this for loop. What I get to right here, we've seen it already. There is no I. So I can redefine it. So the advantage of for loops for counting is that usually when we're counting, we're using little throwaway variables like that. And even if there's 10,000 lines separating these two loops, if I did all my counting with throwaway variables in this manner, I know that I can always just start with the same variable. I don't need to come up with, AA and AAA for dealing with all these different throwaway variables. So I can have two for loops right in a row, both counting on I, and I lives and dies with each one individually. Make sense? Okay. Now, let's look at a do-while loop. So we looked at our for loop and our while loop. Now remember, back here to our three kinds of loops, we have while loops, which are pre-check loops. We have for loops, which are pre-check loops. Then we have do-while loops, which are actually post-check loops. do while loop. We're going to do opening curly brace, the logic to repeat as long as the Boolean expression is true, closing curly brace, while Boolean expression, semicolon. Remember, this type of loop lends itself to problems that must execute at least one time. So to print out the numbers between 1 and 5, that would be our code. To find a variable named I, start it off at 1, start our do loop, the word do, followed by an opening curly brace. Do must be lowercase. We'll print out current value of I, which is 1. 1 becomes 2. Keep doing this as long as I is less than or equal to 5. So this will print out all the numbers between 1 and 5. I'll show this to you inside of Eclipse. Int I equals 1, do system.out.println I is equal to I plus 1. While I is less than or equal to 5. Okay? And notice that there's a semicolon here at the end of that line. So, the output of that will be 1 through 5. Well, it's the same output as we had before. Correct? Okay. Well, let me comment out this. Let's uncomment out our while loop thing here. So what will the output of this while loop version of a program be? Same thing, 1 through 5. What will the output of this program be? I have not heard the right answer yet. It's not 1,000 and it's not 0.
1001.
Not 1001. Well, now we're just guessing. While loops are pre-check loops. What does that mean? What does it mean for a loop to be a pre-check loop? Checks the Boolean expression before it executes anything. What does I start off as? 1,000. Is the 1,000 less or equal to 5? No. What's the output of this program? Do I print anything? So the output of this program is nothing. Not a 0, not a 1, not a false. I literally output nothing. I don't write anything. Because I never get inside this loop. Right? I starts off as 1,000. Is 1,000 less or equal to 5? Nope. Okay. I'm done. Hit the end of the loop, keep going through all these comments, done with the program. All programs begin and end with main. So this program literally has no output.
So in this case, does it open up an error message right
No, there's no error. This is a perfectly functional program that has no output. Yeah, I mean, there's nothing wrong with this code. It just happens to never get inside this while loop. Make sense? Come back up here. Again, this is 1 through 5, right? What will the output be now? Okay, so the output would be 1,000. Because we defined I to be 1,000 right here. Do while loops are post-check loops, which means that we execute the body of the loop at least one time. So starts it off at 1,000, prints out 1,000. 1,000 becomes 1,001. Is 1,001 less than or equal to 5? No. So we're done. We will not loop back up and do it again. So the output of this is 1,000. Make sense? Okay. So questions about those loops? Okay, so I'm going to give you, this will be an ungraded quiz. Ungraded, so you can either do this on a piece of paper or do it in your head or write it on your computer, whatever you want to do. I'm not going to collect it. It's a question. So I want you to write a loop that will print out all of the even numbers between 1 and 100. So I'll give you about 5 minutes. Think through that. Print out all of the even numbers between 1 and 100.
rather than like doing this the easy way, like say applying this to more complicated stuff, could you make one that like it takes each number from 1 to 100, like each individual integer, like 1 and then 2 and then 3, and it takes 1 and then like divides it by 2 and then sees if it's an integer and then we'll print it? Like, can you say something like, can it verify if it's an integer?
You wouldn't be. But the short answer to what you're asking is yes, you can do that. But you wouldn't be checking to see if it's an integer. You'd be checking to see if it was a very specific integer. If you divided a number, an even number divided by 2 has a remainder of 0.
Oh, so you're checking to see if there's a remainder of 0?
Correct. You don't have to do that in this case.
I know, I'm just curious if, like, you, because, like, for more complicated stuff, maybe that would apply.
Absolutely. Yep, and that's that modulus thing we talked about last class. Remember that from the videos?
I don't remember it.
Oh, we did the 3rd grade math, the integer division, where you had something, remainder, something else.
Okay. Vaguely.
Yeah, it's in there. That percent, the percent symbol operator. So,
Thank you. Thank you. Thanks.
yeah, this guy right here. So this is the modulus operator for your last one. And then here we're, example. 13 divided by 5 is 2 remainder 3. So 13 divided by 5 is 2. 13 mod 5 gives you the 3. That's the way of looking at the remainders.
Oh. Wait, what's the symbol for then does not equal? Like,
It's
I forgot.
exclamation point equal sign.
Yeah,
This guy right here.
Thanks.
But one more minute. All right. So, the most straightforward way of doing this would be for int I is equal to 0, I is less than or equal to 100, I is equal to I plus 2. So add 2 to I each time instead of adding 1 to I each time. So it'll go from 0 to 2 to 4 to 6 to 8, so on and so forth. Make sense? Okay, so that would be the most straightforward way of doing this. If we want to do it the integer division way of doing this, we'll say I equals 1. Keep going as long as I is less than, I is 0. Keep going as long as I is less than or equal to 100. I is equal to I plus 1. Then we'll ask a question. If I mod 2 is equivalent to 0, system.out.println I. So this loop will take I on a voyage between all the numbers between 0 and 100 inclusive. So including 100 because I said less than or equal to. Each time through it'll ask the question, is the current value of I, when divided by 2, does it have a remainder equivalent to 0? If it does, that means 2 went into I an even number of times, and therefore I is an even number. So if this is true, then print out the current value of I, but only if it's true. If it's false, fall past the if statement, spin back up to the next loop through the for loop, and come in and do the next I. Same output. That make sense? All right, questions about that? Okay, so I'm going to now introduce our next concept that we'll start talking about next class. But it won't actually be part of what you'll be doing in your homework assignment. So I think you have everything you need right now to do your homework assignment. In fact, here we'll talk about the assignment here real quick, but I won't talk about how to do it. Okay? Just know that everything that you need to do it, you've learned in the class so far, between last class and this class. All right, so your homework assignment for next class, for your Java one, is write a Java program that counts the number of numbers between 1 and 1 million that are evenly divisible by 9, 13, 27, or 81. Your program should display the total count to the screen. So you are counting the number of numbers between 1 and a million that are evenly divisible by 9, 13, 27, or 81. Make sense? If there's 56 numbers between 1 and a million that meet that criteria, then your program should output 56.
56, not the 56 individual numbers.
Correct. The number of numbers. Make sense? So that's the program question. The paper question is one that is almost always hated, FYI. So this one is write a 3 to 5 page paper describing the use of Java in the first Intel version of the Solaris operating system made by Sun Microsystems. So we mentioned that a little bit today, that Sun was a hardware company, also made software, and Solaris was one of the prime platforms that Oracle ran on. Okay, so discuss the use of Java in the first Intel version of the Solaris operating system by Sun Microsystems, now Oracle. The paper should contain at the least topics related to performance, security, hardware compatibility, and user experience. This one might take some digging because there's plenty of information about Solaris out there. But specifically, I'm asking about the Intel version of Solaris. So just to give you a little bit of background on this, so you kind of know what to look at. Solaris existed for a very long time. Solaris operating system existed for a very long time. And it was always made for Sun's Spark processor. That is not an Intel processor. Then they decided, as Intel became more and more popular, that, you know what, we really need to port our operating system over to Intel processors so that people who are starting to buy server hardware running Intel processors can also run our software. Furthermore, so that we can start selling hardware running Intel processors rather than the Spark chips that we're famous for, because Spark chips are becoming very expensive to make and they're not really keeping up with the performance of the newer Intel chips. So there was a need to create an Intel version of the Solaris operating system. Having said this, this was during the time period where Sun Microsystems was very, very, very pro-Java. And kind of before the time period where they recognized that Java was a performance problem. Probably don't want low performance operating systems, right? Okay. So in any case, what I'm asking you to investigate is how Sun used Java in the creation of their Intel-based version of the Solaris operating system. The punchline is they overused Java in the Solaris version, the Intel version of the Solaris operating system. But I'm asking you to get me some details on that. Okay? So it's specific to that transition. When they finally ported it, I think it was Solaris 8. I think was specifically the version of Solaris when it was first available for Intel. Don't absolutely quote me on that, but you can almost quote me on that. I feel very confident, like 97.36% certain I gave you correct information. That Solaris 8 is the version of Solaris where this took place. But do fact check that. That make sense? All right, so those are your assignments for next week. I should have your first assignment, your first two assignments. I would expect them to be graded, let's say, end of day Saturday. I hope to get to it this week. My wife's been pretty sick, so it's all related to my sleep schedule. But worst case, it'll be a breakfast Saturday morning event. And there's not that many of you, so sometimes this class has 25 people in it, and those papers become more problematic. But I think with just a couple of people, I can get it to you by Saturday night. I'm hoping to actually get it to you tomorrow. I'm just trying to under promise, over deliver is my goal. All right. So questions about the homework at all before I dive into our kind of start the flow towards our next topic? Okay. So remember when we talked about, why is that slide up there? I need to go back. Okay, this slide. There are two types of variables. We have our primitive type variables, a variable type built into the language which is only capable of holding a single value. We've messed with those a lot, right? Actually, we've messed with integers a lot. Actually, since I brought this up, let me just show you kind of a cool example. So pause where I was about to go. this is actually not going to work like this. Don't ask me about that operator. I'll teach it to you shortly, but right now I want to get into something else. Oh, heck, I'll just talk about it. Okay. So, this guy is the increment operator, plus plus. So, if I have an integer I, here, let me just do it like this. Int I is equal to 5. I is equal to I plus 1 is the same thing as saying I plus plus. Is the same thing as saying same thing as saying plus plus I. Those are all synonyms-ish. They all ultimately have the same result. So I is equal to I plus 1 ultimately boils down to I being 1 greater than it used to be. Saying I plus plus ultimately boils down to I being 1 greater than it used to be. Plus plus I ultimately boils down to I being 1 greater than it used to be. Okay? Similarly, I is equal to I minus 1, I minus minus, and minus minus I all ultimately boil down to the I being 1 smaller than it used to be. Okay? Now, they do have some interesting caveats here. So I'm just going to actually cut that code for a second. So if I say int I is equal to 5, and then I say system dot out dot println I, this is going to print out a 5, correct? 5. Then if I say I is equal to I plus 1, and then I say system.out.println I, it's going to print out a 6, right? Okay, makes sense? Nothing up the sleeves. All right, so what will print out here? Of course, this will print out 5 and 5. But what will print out here? That'll print out my 6. So as promised, ultimately the outcome of this is the same as the outcome of I equals I plus 1. But when the plus plus comes after the I, and I'm using it in line like this, which I would rarely recommend. In fact, I would not recommend using it like this. I'm just doing it to show you the caveats of this. Since the plus plus comes after the I, when I'm using it in line like this, I get the value of I now, and then I changes to 1 bigger than it used to be. Because the I comes after. It changes after. Okay? That's why I have, well, I'm missing my pointer. Things crashing again. I no longer have a pointer, it's fine. So, good thing class is almost over. All right, so, it's just weird. Oh, there we go. Got it. All right, this machine probably needs a reboot, doesn't it? Gotta give it some rest tonight. All right, so does that make sense? So I ultimately did become 6. It did become 1 bigger than it used to be. But when I printed out the value here, it gave me the current value of I and then changed I afterwards. Similarly, plus plus I would change it first, then give me the new value. So this will print out 5, then it'll print out 6 because the change happens before I get the value. Then I'll print out a 6. So this will be 5, 6, 6. That make sense? Now, what I'm telling you is there really isn't a very good reason other than showing off for you to ever have inline things like that. That's 99.9% true. I can come up with actually, I don't know if I can come up with a great example right now, but I can promise you there are some circumstances where it would be beneficial to do it inline, but it is so rare that it's not worth worrying about right now. So what I'm telling you is, if you'd like to use I++ or plus I, use it instead of saying I is equal to I plus 1. Just because it's shorthand. So instead of saying I equals I plus 1, on its own line, say I++. Or in a for loop, say I++ instead of I equals I plus 1. Okay? So in that case, it doesn't matter whether you say plus I or I++, because it's on a line by itself. It's standalone. We're not relying on what the current value will be. At the end, whether I say I++ or plus I will be one bigger than it used to be. Make sense? Now, if I want to say I is equal to I plus 2, you cannot say I plus. No, it's just for incrementing by 1 and decrementing by 1. So I minus I. So it's a quick way of incrementing or decrementing by exactly 1. That make sense? Okay. So, having said that, here's a for loop. Instead of using a int I, I'm using a char I named C. I could name it I if I wanted to, but I have a char C. I'm starting it off at the character A. Single quote, A, single quote. I'm going to keep going as long as C is less than or equal to Z. And each time through, I'll increment C. I had to show this to you because technically, C is equal to C plus 1 won't work. And you're going to tell me why in a second. But C++ works. And then I'll print out C. The output of this will be the alphabet. That make sense? Why? Why does this work? Go ahead.
Because C is a character, you define it as a character.
Okay. That's a true statement. But I'm adding to character. I'm doing math with characters. Doesn't make sense, does it? Isn't a character things like A and Z? So why does this work? You know everything you need to know to answer this question. I'll give you a hint. It's from last class. Okay, keep going. It's not because it's unsigned, but we're in the right conversation.
Because it's not, char is not an integer?
You're very close. Char is an integer. Chars are integer types. Right? We talked about that last time. A char is represented, here's the slide. Let's see where we got it in here. Primitives. A char is a 16-bit unsigned integer. But it looks like a letter, A or B or C or D or a question mark. You know, why is it an integer? Why are chars integers? Specifically, why is it a 16-bit unsigned integer, which just happens to be 0 to 65,535? Why is that range that range?
To get the letters, it's like in ASCII, a letter is it's numbers plus so many more.
Okay. So what's ASCII?
Character set.
ASCII's a character set. Okay. How many characters are in the ASCII character set? 256. So what do I need 65,536 numbers? Which is what character set? Unicode character set. Java uses the Unicode character set. So even though chars ultimately map to characters, they're represented as integers, and it's using the Unicode lookup table to map those integers. Does that make sense? So, an interesting thing you can do, just since we only have a couple minutes left, I won't jump into the next thing. I'll tell you a little bit about something called typecasting. Now's as good a time as any to do that. So typecasting, this allows me to turn a primitive type into another type. We'll turn any type into another type as long as it makes sense. So for instance, I can say int a is equal to the integer version of 3.14159, something like that. Maybe more to the point, I can say double D is equal to 3.14159, because doubles can hold decimal point values, right? And I'll say int a is equal to the integer version of D. What is the integer version of D equal to? Well, this is the double version of D is 3.14159. Integers can't hold decimal places. So what's the integer version of D? 3. Truncates. What if D was 3.9? What's the integer version of? Is it 4 or is it 3? It's 3. It truncates. Doesn't round, it truncates. It cuts off everything after the decimal point. Okay, so when I'm going from a double to an int, it does not matter what these numbers are afterwards. It truncates them because an int does not know how to hold it. So if I were to print out a after this line, it would print out a 3. Just to show that to you real quick. Here, I'll just get rid of this for a second. Double D is equal to 3.14159. Int a is equal to the integer version of D. So I'm typecasting D. This is how you typecast. In parentheses, you put the type you want to cast it to. I'm typecasting D into an integer. So I'll do system.out.println D, and then I'll do system.out.println A. And we'll see that A is 3, D is 3.14159. Similarly, if I change D to 3.9, whatever, it will still be 3.9 and then 3. Make sense how typecasting works? So because of that, an interesting thing we can do with this new typecasting knowledge is we can create a for loop for int I is equal to 0. I is less than 65,535. I plus plus. I can say system dot out dot println the char version of I. So I'm going to go through all the numbers between 0 and 65,535, and I'm going to print out each of those numbers typecast to a char. This should show me all the characters in the Unicode character set. Does that make sense? So I'm taking the number 64, and I'm saying, give me the char version of that. Do the map lookup. Now, what we're going to find here is that the terminal that's part of give me a second, I will get to this thing in my head, that's part of Eclipse, doesn't know about the entire Unicode character set. So we're going to see a bunch of question marks for some of these. Okay, so I'll go ahead and run this. I ran out of space, great. Let me do it this way then. Copy that code, get over to our terminal. vi who.java. I'll paste this in there. I won't even worry about indenting. We're pretty much out of time, so I'll write that. Let me go to my preferences here. I'm going to do UTF-16. I think that'll let me show all of them on here. I guess we'll find out. So I'll compile it, run it. No, same problem. Well, here, I'll show you something interesting then. I'll pipe that to something called more. So this will let me see it one screen at a time. So there's going through our alphabet. And then we start getting into some crap we can't show. Then we start getting into some stuff we can show. And even those, I don't think are being interpreted correctly. You should be seeing like Chinese characters and stuff like that. But I'm sure there's a terminal setting I can set to make sure to teach it to translate all the Unicode characters, but it's not doing it. But trust me, it's doing it. Trust me, Java's doing what it's supposed to be doing. Okay? Questions, comments, concerns, bribes about any of that?
Is this right?
All right, I'll see everybody on next Wednesday, right? I'll get the lecture uploaded.